I have a dream that one day
Tutorial 1 deals with the basic application of the laws of exponents. I'm assuming that you've watched and worked through lesson 1. If you don't have a PDF format of this tutorial, please pause here and try these questions first before you look at the answers. In the first question here, we are multiplying and the bases are the same, so we can add the powers. A plus times a minus is a minus, so it's 3 to the 4 minus 1, which is 3 cubed, and this is 27. Here we are dividing and the bases are the same, so we can subtract the powers, and we get 2 to the 1, or just 2. In number 3, we have brackets, so we can multiply the powers, 2 times 4 being 8. And we can check on a calculator. 3 to the power of 8. 6561. In number 4 here, we have a fraction raised to a power. We can apply the power to both the numerator as well as the denominator. So it's 3 cubed, which is 27. Over 5 cubed, which is 125. We have a negative power here, so we can invert the 3 and write it as 1 over 3 to the positive 4. So the power becomes positive, and this is 1 over 81. Here we have a fraction raised to a negative power. We invert the fraction, and the power becomes positive, and now we can apply the power to both the numerator and the denominator. And once again, for 4 to the 4 is 256, so it's 256 over 81. In number 7, we know that anything raised to the power 0 equals 1. In number 8 here, we are multiplying and the bases are the same, so we can add the powers. A plus times a minus is a minus, so it's 2 minus 3 as a power. And this is 4 to the negative 1, which we can invert and write as 1 over 4. We can invert the 4. In number 9, we have brackets. So we can apply the power. We can multiply the power outside the brackets with the powers inside the brackets. So it's 3 cubed times 2 to the 6th, which is 27 times 64. So 27 times 64, 1728. Here 3 is raised to the power 0, so it's going to be 5 times 1, which is just 5. In 11, everything is raised to the power 0, so this is equal to 1. And in number 12, we can divide the power here by 2, because we have a square root. So it's 3 to the 4 divided by 2, which is 3 squared. And that's equal to 9. In number 13, we can divide all the powers under the square root by 2. So 6 divided by 2 is 3, so we get 2 cubed. 2 divided by 2 is 1, so we get 3 to the 1, or just 3. And negative 2 divided by 2 is negative 1, so we get 5 to the negative 1. 2 cubed is 8 times 3 is 24. The 5 to the negative 1, we can take into the denominator as 5 to the positive 1. Here we first deal with what's inside the brackets. We can divide the powers underneath the square root by 6. So it's 2 divided by 6 is a third, so it's 4 to the 1 over 3. And 4 divided by 6 is 2/3. So it's 3 to the 2/3. And this is all to the power of 3. Now we can multiply the power outside the brackets by the powers inside the brackets. A third times 3 is 1, so we're left with 4. 2/3 times 3, of course, is just 2. So it's 3 squared. So we get 4 times 3 squared, which is 9. And this comes to 36. We're dividing here, so where the bases are the same, we can subtract the powers. So 2 to the 3 minus 1 is 2 squared. Then we have 5 to the 2 minus negative 1. 2 squared is 4. A minus times a minus is a plus, so it's 5 to the 2 plus 1, which is 5 cubed. And this is equal to 500. We first deal with the brackets in the numerator. So we can multiply out the powers. So it's 3 to the 4 times 4 to the negative 2. Now we can subtract the powers where the bases are the same. So 4 minus 1 is 3. And here we have 4 minus 2 to the minus 2 minus negative 3. So 3 cubed is 27. And we have 4 to the negative 2 plus 3. And that's just going to be 4 to the 1. So 27 times 4 is 108. In number 17, we first deal with what's inside the brackets in the numerator. We can divide all the powers underneath the cube root by 3. So it's 5 to the 2/3 times 3 to the 4 over 3. And this is all to the 6th. Now we can multiply the power outside the brackets by the powers inside the brackets in the numerator. So 2/3 times 6, 3 into 6 twice times 2 is 4. So it's 5 to the 4. 3 into 6 twice times 4 is 8. So it's 3 to the 8. Now we can subtract the powers where the bases are the same. Of course, it's a 1 here that we don't write. So 5 to the 4 minus 1 is 5 cubed. And 8 minus 5 is 3. So it's 3 cubed. So that's 125 times 27. And we can find this on a calculator. 125 times 27. 3375. In number 18 here, we can take the 2 to the negative 3 into the denominator as 2 to the positive 3, and 5 to the negative 1 into the numerator as 5 to the positive 1, or just 5. So then we get 20 over 8, and simplifying this, 4 into 25 times, and into 8 twice. Here we can take the 3 to the negative 2 into the denominator as 3 to the positive 2. And we have 7. 3 squared is 9 times 8 is 72. So 7 over 72. In the first term here, we can divide the 6 by 3. So it's 5 squared. We can multiply the power outside the brackets by the powers inside. So it's 2 to the 4 times 3 squared. 1 times 2 being 2. 5 to the 0 is 1. So that's 25. 2 to the 4 is 16 times 9. And we can do this on a calculator. 25 plus 144. 16 times 9 being 144 plus 7. And this is 176. So we can multiply the numerical coefficients first. 3 times 2 is 6. We add the powers of the a's, so it's a cubed. And then adding the powers of the b's will be b cubed. 5 goes into 10 here twice. And we subtract the powers where the bases are the same. So it's x to the 2 minus 3. In other words, x to the negative 1. And then subtracting the powers of the y's will give us y squared. We can now take the x to the negative 1 into the denominator as x to the positive 1, or just x. So it's y squared over 2x. We can apply the power outside the brackets to everything inside the brackets. So multiplying the powers will give us 5 cubed, a to the 6th, b cubed. And this is 125, a to the 6th, b cubed. This equals 9p. Q to the 0 is 1, so it's just 9p. Everything here is raised to the power 0, so this is 1. Multiplying and adding the powers of where the bases are the same. So it's going to be 5 to the 3, x to the negative 2, y squared. This is 125 y squared. And we can take the x to the negative 2 into the denominator as x to the positive 2, or x squared. Here we can first simplify inside the brackets. So a squared divided by a, we subtract the powers. 2 minus 1 is 1. So it's a to the 1, or just a. Here it's b divided by b cubed, subtracting the powers. So it's b to the 1 minus 3, which is b to the negative 2. And the c's cancel. This is all squared. Now we can apply the power outside the brackets to everything inside the brackets, to both the numerator and the denominator. So we get 4 squared, a squared, b to the negative 4. We are multiplying these powers, the powers of each of these factors, by 2. And this is all over 3 squared. So we have 16 a squared, and b to the negative 4 we can move into the denominator as b to the positive 4. 3 squared, of course, is 9. Once again, first simplifying inside the brackets. So subtracting the powers of the p's, we'll get p squared. We can move the q to the negative 2 into the numerator as q squared. Now we can invert the fraction and the power becomes positive. So it's going to be 5 over 2p squared q squared to the positive 3. And finally, applying the power to both the numerator and the denominator, we're going to get 5 cubed, which is 125, over 2 cubed, in other words, over 8, p to the 6th, q to the 6th. Here we are multiplying the powers of the p and the q by 3. We can divide all the powers under the square root by 2. So it's 3 to the negative 1, x squared y, and we can move the 3 to the negative 1 into the denominator as 3 to the positive 1, which is 3. We're first going to work inside the brackets here. So dividing all the powers under the sixth root by 6, we get 2 to the half, 3 divided by 6 being a half, x squared y to the 1, which is y. We can multiply the powers inside the brackets by 2 now in the numerator. So a half times 2 is 1. So it's just 2 to the 1, or just 2. X to the 4, y squared. Now we can subtract the powers where the bases are the same. So 2 to the 1 minus 2 is 2 to the minus 1. Then x cubed, y to the negative 1. Now we can move 2 to the negative 1 and y to the negative 1 into the denominator as positive powers. So just 2 to the plus 1, or just 2, and y to the plus 1, or just y. So we have x cubed over 2y.